What's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we are going to take a look at some polynomial theorems. The very first thing we're going to look at is converting to standard form. So go ahead and grab your pens, your papers, your notes, and I want you to go ahead and get to work on this warm-up that's right here and see if you can factor the first trinomial correctly and then use synthetic division to correctly determine if x equals -1 or x equals -3 is a root to the polynomial function that you're given. So go ahead and hit pause, try those on your own, then let's come back and see how you did. All right, so how did you do with that one? Hopefully you were able to come up with the correct factors of 3x plus 2 and 2x minus 1 for the first part of our warm-up. And again, those could be in either order, so you could write that the other way. You could write 2x minus 1 first, and then 3x plus 2 second. It doesn't matter what order you write them in, as long as you have the correct terms grouped together in the same set of parentheses. Now the second one, this is one where you got to be really careful because when you look at the polynomial x cubed minus 7x plus 6, there is no x squared term. So be careful. Don't forget to add the 0 in there as a placeholder. And when you do that, you'll end up with 12 as your last term when you use -1 as your root, which means -1 is not going to be a root because in order to be a root, that last term when you use synthetic division should be a 0, which it is in example B when you're looking at x equals -3. So be careful, make sure that you have all the terms from the highest degree all the way down through the constant. So with that said, let's go ahead and get into our very first couple of problems here where we take a look at converting standard form to factored form. Now, to do this, we're going to need a root or a factor. And in the beginning, we're going to give you what that root or factor is. Later, we'll have to actually find one that works and then go through the same process. So for this, we're told in example number 1 that 2 is a root. So we're going to put 2 right here. The next thing we're going to do is we're going to analyze that polynomial. So I start, my highest degree is 3. So I want to count to make sure I've got all the terms from the highest degree, 3, a 2, a 1, and then a constant. And in this case, I do. So that's awesome. I don't have that much to do. I'm going to just put a 1 because that's the coefficient in front of x cubed. 1 is a coefficient in front of x squared. -4 is a coefficient in front of -4x. And our constant is -4. So we'll just write those in order going straight down. Now remember, we're just going to bring down that first term, and then we'll get a value of 1 right there. Now you're going to multiply 2 and 1, so that gives you a product of 2. Add up 1 plus 2, and you get 3. And then 2 times 3 gives you a product of 6. When you multiply or combine 6 and -4, their sum is going to give you 2. 2 times 2 lastly is 4. And notice we get 0 there, so that's awesome. That's amazing. We are done with that, which means what's left? So sometimes I like to put a c there for a constant and then an x and then an x squared. And I'll just kind of start rolling that way because then that tells me I'm going to have x squared plus 3x plus 2. That is going to be my next polynomial that I have to factor. So when I go to factor this, again, you've got a couple options here with this. And if you just straight go to factoring and you're using some number sense, the only way to factor x squared is going to be x and x. Now when I analyze this last term here, plus 2, that last term, being plus 2, is going to actually be positive 2. And the only way to get positive 2 is either multiplying 2 negatives or 2 positives. And because 2 is a prime number, it doesn't matter. I'm going to put 2 there and 1 there. Now I analyze my middle term, my linear term, that 3x, and 3x is positive, which then tells me both of these are going to be plus. So that's one option you could use to factor this. The other option you could, of course, use box method. And if you're going to use box method, you know, that's your jam. Go ahead and use the box method with that. And on the inside, we'd have x squared. and then we'd have 2 right there. But then we got to break up that 3x into a couple different terms, and one of them is going to be 2x and x because the sum of those two will give me 3x. Now I take out my GCFs depending on which way you want to do it. If I go down the column, I'm going to have x here and then plus 2 right there, and then going along the left hand side I'm going to take out an x there as well, and then between x plus 2 there is no common factor other than 1. So that's why that guy is plus 1. So either way you slice it or dice it, you'll get x plus 2 times quantity x plus 1. So when I write this in factored form, not only am I going to have those two guys, the x plus 2, x plus 1, but don't forget this part right here that we were given in the beginning. If x equals 2 is a root, then that's going to mean x minus 2 is going to be the factor. So that's going to be one of my factors right there, along with the other two that we just found from factoring the x squared plus 3x plus 2. So that is going to give me this. Now, here's where I want you to be really careful with your notation. Make sure that you write f of x, and then your equals, and then you're going to have the x minus 2 from what we were given, and then the 2 that we just found. And again, the order doesn't matter as long as you have the signs right. You are good. So the factored form of the polynomial we're given for number 1 is f of x equals x minus 2 times the quantity x plus 2 times the quantity x plus 1. So that is that guy right there. Now, number 2, they actually give us the factor, which is really cool because then we don't have to do anything. So we could actually start that off, that factored form. We're like, all right, we got one of the factors. So f of x equals x minus 2. They just tell us that straight up. So we just got to find the other ones, and we will do that using our synthetic division. So if you think you got it, go ahead and just hit pause right now, and let's see how you did with this one. All right, so how did we do the first part of it? All right, you list your coefficients going across 1, 4, negative 3, and 18, negative 18, and then we'll simply do the math as we bring down the 1 and multiply 2 and 1, find their product, find the sum of 4 and 2, and so on and so forth. So we're going to get 0 at the end, which is what we want because that tells us 2 is a root. Now what I'm left with, that x squared plus 6x plus 9, we've got to factor that thing. And some of you might recognize this as a perfect square trinomial. So again, whether you use the box method or factoring using number sense, however you want to get to that, you'll get the two factors. That will be the same in this case because it's a perfect square trinomial, and that is x plus 3 for both factors. So when we go to write that, then that means we will have two options for writing that. You could just write it as x minus 2, that quantity times the quantity of x plus 3, and another quantity of x plus 3. Or you could rewrite that x plus 3 with an exponent of 2. Because remember, we've already talked about multiplicity a little bit, and that's going to tell us when we curve sketch that that root, the x plus 3 factor, when we find that root, that 0, because that 0 would be x equals negative 3, that would bounce right there. Whereas at the other factor, x minus 2, that 0 would pass through. All right, so that's what we're going to do here in this next part. We're going to put all this stuff together by going through the synthetic division, factoring and finding the other roots, rewriting it in factored form, then going through to put together a sketch of this. Now we're going to add one other layer to this now, and that is the y-intercept. And remember, the y-intercept is always going to have the coordinate 0 some number, because the x value will always be 0. So whether you plug 0 into the original polynomial or you plug 0 into the factor form, you will get the same answer. And the thing I love about the y-intercept is you go right to standard form. Because if you look at plugging 0 in for this, like all these terms, gone, gone, gone. The only thing that you're left with is the constant. And this guy right here, that constant, that is going to be your y-intercept. So that's something you can get right off the bat when you're given the function that's in standard form. So that's one thing we got figured out. So I can go down here, and since I know that that is going to be at 0, negative 2, I could actually, as I start to graph, I know somewhere 1, 2, I know I'm going to have my y-intercept right there. So that's the first part of it. The rest of it, go ahead and give that a go, because I know we've done this previously in other lessons. So give that a go, and let's see how you do putting this all together now. All right, so let's see how we did putting this all together. Now the synthetic division part, you should be pretty good at. You should be pretty solid at that. And when you go through this, you will end up with another perfect square trinomial. of x squared minus 2x plus 1. That just happens to be the case here. It doesn't always work out like that. So as you go through that, and you factor the x squared minus 2x plus 1, you're going to get the same two factors of x minus 1. Now when we write that, we're going to write that as x minus 1 squared when we go to rewrite the polynomial in factored form. And that's going to help us because then we're going to look at the zeros, right? And the 0 for the first factor, x minus 2, we know that that's going to be at x equals 2. And the second factor, the x minus 1 squared, that is going to give us a 0 at x equals 1. So we're already kind of thinking ahead for where these guys are going to be. Now, when I add up the exponents of each factor, I get a sum of 3. So that means the degree is 3. And when we have a degree of 3, that and my leading coefficient is going to be positive 1. When those two situations happen, anytime we have an odd degree, we're always going to have a line for the end behavior that's going to have a positive slope, or the end behavior could look like the opposite way, where you'd have a negative slope. So depending on whether the leading coefficient is positive or negative is going to tell you which way the ends go. Now, because we've got a degree of 3, positive leading coefficient, our ends are going to go in the opposite direction like it was just a positive sloped line. Now, my first factor of x minus 2 gives me that 0 of 2, x equals 2. My second factor, that's the x minus 1 squared, that gives us a 0 of 1. So x equals 1. My multiplicity, pretty straightforward on that because the degree is 1 for the first factor, and x minus 1 squared, that has a multiplicity of 2, which means the first factor is going to cross, the second factor is going to bounce because we are even in its multiplicity. Now when we have all that, we're just going to kind of put that together. So my first factor and my end behavior, so I know the ends are going to kind of go like this. I only have 2 factors. So 1 and 2 zeros. So 1 0 is right here, the other 0 is right there. My y-intercept, we already plotted that from before. So I'm going to go that way off of that 0. Now the other 0 is going to go down like that. So when we go to finish the graph off, we know that at 1, remember that 0 that bounced, and then at x equals 2 that crossed. So when I come up and hit the 0 at 1, I'm going to bounce right there, curve back around, and then come up and pass through the 0 at x equals 2. Now, when we take a look at the end behavior, so let's talk end behavior here for a moment. So we're going to first take a look at the left side. So this guy right here, and we write that, as x approaches negative infinity. So anytime you see as x goes to negative infinity, that's talking about the left side of the function of the graph. And this one goes down. So our y values are going to decrease. They're going to go down forever and ever and ever, which means then we'll say that f of x is going to approach negative infinity. And then likewise, on the opposite side, we've got our arrow on the right side. That's going up. So we write that as x approaches positive infinity. So on the right side, we're going up. So that means f of x is going to always increase. The y values are always going to get bigger. So f of x is going to approach infinity. Now that's the Algebra 2 way to write that. I know when you guys go on to other courses, you'll write a little bit differently, but more on that later. So that's it for this video. 1 or 2 more because we've got to cover fundamental theorem of algebra as well as rational root and zero theorem. So that's it for this one. Thank you so much for watching, and as always, make it a great day because there's simply no good reason not to. And I'll catch up with you later. Peace out.